So thank you everyone for being here, and thank you to WARF for giving us the opportunity to present. As Leslie mentioned, this is a technology that was invented by Dr. Hanwan Jiang from UW-Platteville. My name is Adira and I'm the Assistant Director of WISIS. And for those of you who don't know, WISIS is a nonprofit that's dedicated to fostering innovation, research, and entrepreneurship on the 11 UW regional campuses, including UW-Platteville. So this technology addresses the problem of America's decaying infrastructure. This is a $123 billion problem. As you can see from this picture, it's a recent bridge collapse in Pittsburgh, Pennsylvania. The toll of decaying infrastructure is more than just a number. It takes a toll on human life, it disrupts society, it disrupts the way we function. Infrastructure is a key component of our modern day life. So 39% of the bridges in the US have exceeded their design lives. And we know this is a big problem and something that's getting a lot of attention now with the $1.2 trillion infrastructure Investment and Jobs Act that was announced relatively recently. So why is this a problem, right? I mean, we've had roads and bridges for centuries, really. So why aren't we better equipped to test them, to monitor them, and to avoid the kind of bridge collapse that happened in Pittsburgh? Well, part of the reason is that the current solutions are inefficient. So state departments of transportation rely primarily on visual inspection of bridges and roads. As you can imagine, that is not a very robust data set that you can get, right? They're literally just walking around under the bridge and looking up at it. So why is it that, given all of the advancements in sensor technology, that this isn't being implemented, right? Well, the problem is that current testing methods are expensive, they require extensive technical training, and more importantly, they disrupt traffic. As anybody who's been on a bridge knows, you do not want to shut down a bridge for a day and a half to test the cracks on it. There's also no regulation that mandates testing of these bridges. The complexity of the post-processing of the data is also a big barrier in terms of the cost and time and effectiveness of these technologies. I really like this quote from the Pennsylvania Department of Transportation because it sums up the problem beautifully. So this was from a recent survey that was conducted by the US Department of Transportation's Federal Highway Administration. And most of the states in that survey were interested in improving their testing methods and the frequency with which they tested. But as this quote says, uncertain accuracy in the non-destructive testing results and the time and costs involved to get final results are the main barriers to implementing NDT, which is non-destructive testing, on bridge decks. So what are we going to do about this? Well, this new technology that's coming out of Platteville, it's an ultrasonic monitoring system aimed towards solving some of the pain points that are associated with regular monitoring and testing of infrastructure and concrete structures. So by combining sensor technology with an ultrasound signal generator, multi-channel data acquisition, and proprietary data processing algorithms, the interior conditions of any cross-section of a bridge, or really any concrete structure, can be visualized three-dimensionally. So with this technology, small stress changes on the order of 0.1 megapascals and cracks as thin as the human hair can be detected. But more importantly, the advantages of these technology is that it can assess full-size, large volume structures. It has high sensitivity, and it can provide real-time three-dimensional images, at least to a certain fidelity. So what this means is that it can be used on in-service structures. You don't have to shut down the bridge to test and use this technology. It is also a platform technology, which I'll get to in just a second. So this technology has been developed, tested, and validated. A fully functional prototype system has been developed in the laboratory and field tested at the, I'll try to say this, it's a little bit of a tongue twister, at the Berwick Bay Bridge in Louisiana, which is a vertical lift bridge. So they tested this technology and compared the results with kind of the existing standards of testing, And the results, were incredible. I mean, they were able to get a really accurate health assessment of this bridge, and they were able to do that without shutting down the bridge. In fact, they could see how the bridge was reacting when a car or a truck drove over it. So, as I mentioned, this is a platform technology. The non-destructive testing market is a $25 billion market, estimated to be $25 million by 2026. So some of the other applications where this can be used is oil and gas pipelines, power plant inspections, aerospace, mining, and even something like lithium-ion battery health monitoring for our electronic vehicles. So what we're looking for with this technology is partners, industry partners, or startup founders who are interested in bringing this technology to the next stage and really implementing and validating the market piece of this technology. Our inventor is still very much involved. She's no longer in the UW system, but she's willing to assist with any technical development and any future development that might be necessary for this. So if you're interested in this technology or connecting with the technology and innovations that are coming out of the other 11 UW regional campuses, please contact me. And I'll also put in a plug. We are having our annual conference this summer at UW La Crosse called Spark 2022. So if you're interested in attending, it's a showcase of all of the innovation that's happening across the state. So thank you very much.